Okay, today we're going to start algebra proofs. I'm going to warn you ahead of time, there may be some disruption in the background because they're working on the PA system. So here we go. Today we're doing algebraic proofs. So a proof is a written account of the complete thought process used to reach a conclusion. So these are some of the properties of equality for real numbers. Reflexive, A equals A. In other words, it's equal to itself. The symmetric property, if A equals B, then flip it, B equals A. Then there's the transitive property, if A equals B and B equals C, then A equals C. And I always look at it like this, A equals B, B equals C. Those two cancel out, so A equals C. Then there's the addition and subtraction properties. If A equals B, then A plus C equals B plus C. Notice the C's are equal to each other. So if I were to subtract them, because you know what you do to one side you have to do to the other, the C's are going to cancel out, so that means A equals B. Same thing, if A minus C equals B minus C, if I were to add a C to both sides, the C's would cancel out. So that's why it's the addition and subtraction property. The multiplication and division property, if A equals B, then A times C equals B times C. Because if I divide both sides by C, A equals B. And if C does not equal 0, then A over C equals B over C. Because if I multiply both sides by C, the C's cancel and A equals B again. Then there's substitution. Just like you substitute something in place of another, if A equals B, then A may be replaced with B in any equation. Then there's the distributive property, which you all know. If you distribute A to the B and the C, you get AB plus AC. So now using our properties, let's get started. So here are all the properties. I just made it smaller. So let's go. If x over 2 equals 7, then x is 14. So what do I need to do to get rid of the 2 in the denominator? So I would need to multiply both sides by 2 so that I could get x equals 14. So your property would be multiplication property. If x equals 5 and b equals 5, then x equals b, because the 5's are going to cancel out. So we use the substitution property. If xy minus ab equals wz minus ab, what do we get? Well, we get that xy is equal to wz, because if I add ab to both sides, the ab's cancel out. So then we're left with addition property. If EF equals GH and GH equals JK, then these two GH's are going to cancel out, leaving us with EF and JK. That would be the transitive property. And then, of course, we've got 2 times x plus 3 equals 12. Well, how do I go from here to here? What did I have to do? I had to do what? I had to distribute. So then we would use the distributive property. So what we're going to do is we're going to write 2-column proofs. And we're going to do it using algebra to get us going. The first statement is always what is given. So this first thing is always going to be this. The last statement will always be what you're proving. So this will always be first. This will always be last. So let's get started. So 3k plus 5 equals 17. I'm writing that down because that's what was given. The next thing I need to do is I need to take care of this 5. So what am I doing to the 5? I am subtracting. And then to get rid of the 3, what do I need to do to get rid of the 3? I need to divide. And that's how you do an algebra proof. Okay, let's try another one. 3 times x plus 4 equals 8x minus 18. This is what was given. So now what do? I have to do what to the 3? I have to distribute the 3. Okay, so now to go from here to here, what did I do? I had an 8x here, and then down here I no longer do. So that means I must have subtracted 8x from both sides. And then if you look here, I've got to go from here to here. The 12 is no longer here. So I had to do what to the 12? I had to subtract it. So it's the subtraction property again. And then to go from here to here, what did I have to do to that negative 5? I had to divide by it. So then I used the division property. And that is doing an algebra proof. Okay, the next thing, now we're going to look at some properties, the reflexives, the symmetric, and the transitive, okay? So remember, the first thing is always what's given. So if angle A is congruent to angle B, and angle B is congruent to angle C, that is what was given. If angle A is congruent to angle B, and angle B is congruent to angle C, remember these two things cancel out. So I'm left with A and C. So that means I use the transitive property. Okay, over here I have AB, and I want to prove that AB equals AB. Well, first thing, it's given. Segment AB is given. Well, isn't something always equal to itself? That is the reflexive property. If something is equal to itself. Okay, down here, given, angle M is congruent to angle Y. So I write that down, and it's given. So now, why is angle Y equal to angle M? What's it called when I flip it? It's called the symmetric property. All right, so now let's do one where you have some statements and some reasons, and you have to come up with the rest. So the very first thing I do is I look up here and I see what's given. And I always make sure that I go over here. MN is congruent to PQ. PQ is congruent to RS. I want to prove that these two are congruent. Well, my eyes see they have the same mark, so I know that they are, but I have to prove it. So the first thing I do is I write down what's given. Okay, now remember, here everything is congruent, so we have everything has on a little hat. The MN has a hat, the equal sign has a hat, the PQ has a hat. Everything has a hat. If I take all their hats off, now they're equal to each other, and that's called the definition of congruent segments. So anytime you take hats on, hats off, that is your reason. So now, if MN is equal to PQ, and PQ is equal to RS, the PQs cancel out, leaving me with MN is equal to RS, because it's transitive. Now, RS equals MN, I just flipped those two, didn't I? So that is called the symmetric property, when you reverse the order. Now I'm going from RS equals MN to RS is congruent, so I'm giving everybody their hats back. So remember that definition when I took their hats away? It's the same definition when I give them their hats back. Definition of congruent segments. All right. LM is the midpoint. Well, if LM is the midpoint, I know this equals this. So I'm going to go ahead and mark that. And what I want to do is I want to prove that this segment here is congruent to this segment here. And I know this segment is equal to this segment. So L is the midpoint of KM. Why? Well, it's given. And since I know that L is the midpoint, I can use my inductive reasoning, and I can say KL equals LM because it's the definition of a midpoint. Now, LM is congruent to AB. That's given also. Now I have this. Remember, if KL is congruent to LM and LM is congruent to AB, don't those two cancel out? Leaving me with KL equals AB because it's the transitive property. All right, last one. Taking what I'm given, AC is equal to BD, so AC is congruent to BD. So I really can't put any marks there because of the way they are. So I'm just going to go ahead. AC equals BD because it's given. Now I can take, remember the definition of congruent segments, so they have hats on, so we're going to take their hats off. Now if AC is equal to BC, to BD, and then the next thing they're wanting me to do is segment addition. So think about this. Okay, what if I just looked at this first piece here? AB plus BC. AB plus BC. Doesn't that equal AC? And then what if I used this part down here? Okay, what if I used all this? Okay, so now I've got BC plus CD equals BD. So that would be segment addition. So that's what I'm going to put for my next thing. AB plus BC equals AC. BC plus CD equals BD. So now, remember AC equaled BD in this previous statement? Well, if these two right here are equal to each other, oops, if these two are equal, then aren't these two equal to each other? So then I'm going to put AB plus BC, which is the first half, is equal to BC plus CD. And I'm going to do that by substitution. I'm substituting this in place of this. Okay, now I've got a BC on both sides, so what's going to happen to the BC? They're going to cancel out, aren't they? Because if I subtract BC from both sides, so that was the subtraction property. Well, remember, the last thing you're trying to do is prove this piece right here. Well, I almost have that, except they're missing their little hats. So if I give them their hats back, then that's the definition of congruent segments. So I hope you guys understood and have a good time. See you later.